Hello everyone. So today we are going to solve the paper 1 of physics, January 2020. Let's start. Question number 1. The passage describes some of the properties of magnets and magnetic fields. Use words from the box to complete the passage. Each word may be used once, more than once, or not at all. The north pole of one magnet will repel the blank pole of another magnet. We know that two magnets only repel each other when the north poles are facing. So here, as it is already said, that one magnet will have the north pole facing towards the another pole of magnet. So we all know that the another pole must be north, so that's why they will repel each other. So the pole of another magnet should be north, so it is north. We chose the word north from it, so let's cut it down from the box. There is attraction between dash and magnets. So we need to choose a word that is for a material that is attracted to magnets. We know that it would be steel, because steels have naturally magnetic properties. So the blank would be steel. The materials that are difficult to magnetize are called, we all know that materials like steel, they need a lot of time to get magnetized, and they are called hard magnetic materials because they took lot time to magnetize, and then they again took lot time to become demagnetized. So that's why they are considered as hard magnetic materials. So that in the blank it would be hard. The direction of magnetic field lines for a magnet is from always north to south. The magnetic field lines always come out of the magnet from the north and goes inside the magnet from the south. So the direction of magnetic field lines from a magnet is always from north to south. So here it will be north. The iron the iron is a dash magnetic material. We all know that iron takes a lot less time to become magnetized and again a lot less time to become demagnetized. So it is considered to be as a soft magnetic material. So soft magnetic material. So with this, the question number 1 ends. Moving to question number 2. The ship floats on the surface. The ship floats because of the forces acting on it. The upward force acting on the ship is called upthrust. The force is shown on the diagram. Draw another labeled arrow on the diagram to show the other vertical force acting on the ship. We know that the other vertical force acting on it will be the weight of the ship, and as the force is in balanced position, so the length of the weight should be equal to the length of the upthrust, because the length of the arrow indicates the magnitude. So let me draw approximately same length and straight arrow towards down and label it as weight. Make sure that the length of the two arrows are equal, because the length indicates the magnitude of the forces, and as the ship on the surface of sea is balanced, so that means the vertical forces acting on it are balanced to each other, so they must be of equal length and opposite in direction, so that they cancel each other out. Moving to part 2. Forces are vector quantities. State what is meant by the term vector quantity. We know the quantities that has both magnitude and directions are referred to as vector quantities. So let's write. It is a quantity that has both magnitude and direction. Give another example of a vector quantity. So another example of a vector quantity could be anything like acceleration, velocity, momentum. So let's write any of this. So I'm going to write velocity over here because it is also a vector quantity. Moving to the next part. The upthrust force acting on the ship is proportional to the pressure difference between the bottom of the ship and the surface of the surface of the sea. The pressure acting on the ship at the surface of the sea is 100 kilopascal. State the formula linking pressure difference, height, density, and gravitational field strength. We all know the equation would be pressure difference is equals to height into density into gravitational field strength. So this is the equation linking the terms. And moving to part 2, the bottom of the ship is 15.8 meter below the surface of the sea. So 15.8 is the value for the H. Show that the pressure acting on the bottom of the ship is approximately 260 kilopascal. Density of the seawater is 1030 kg per meter cube. So this is the value for density, and the value for the gravitational field strength, we all know that's 10 meter per second square. So as we need to find the pressure difference, here the pressure difference will be a little different calculations, because the ship is also experiencing a force from the surface of the sea that is 100 kilopascal. So we need to add this to the pressure difference also. So the pressure difference would be the total pressure difference on the ship would be height into density into gravity plus 100 kilopascal. We need to add this because this was also acting on the ship while it was on the surface of the sea. So the height was 15.8, density was 1030, and gravity was 10. And with this we need to add 100 again. And if you calculate it, you will get a value of 162 kilopascal, and it has already 100. So 100 plus 162 is actually 262 kilopascal. Now this is not the exact thing, like the question asked you to give your to show that your answer is approximately 260. So as we can see that 260 is close to 262 is close to 260, so we can just write 262 kilopascal. We don't need to round it up to as 260 kilopascal. That would be wrong, because they said approximately. Approximately means almost. So we did got a value for pressure difference that is almost 260 kilopascal. So that's why we do not need to round it up our answer to make it exactly the thing that is given in the question. Whenever the question says approximately or about, you can obviously put your answer in this form, that is almost close to the given value but not exactly the given value. Moving to part 3, explain why the bottom of the ship is deeper below the surface of the sea when the ship is fully loaded with cargo. We know that when it is loaded with cargo, the weight of the ship increases. And now to balance the weight, to keep it floating on the surface of the sea, a larger upthrust need to act on it. So for a larger upthrust, the ship need to go deeper into the sea, because as the thing moves deep inside the sea, the pressure difference increases. As the pressure difference increases, the upthrust also increases. So that's why it needs to be more deeper in the sea when it is filled with cargo. So let's write. The first point here would be because the weight of the ship increases, therefore a larger pressure difference, therefore a larger upthrust need to act on it to keep it floating. Upthrust need to act on it keep it floating. So the pressure difference also increases as as it moves deeper into the water. Into the water. So this was the end of question number 2, and now we're moving to question number 3. This question is about electric currents. Which quantity is defined as the rate of flow of charge? We know that it would be current because the formula for current is I is equals to Q by T, so which actually means the rate of flow of charge. So the answer should be option A. Which quantity is defined as the energy transferred per unit charge passed? It will obviously be voltage, because we can write voltage as energy by current and time. So obviously it will be voltage. Diagram 1 shows an electric circuit with two resistors R and S. Some of the values of the current are also shown. On diagram 1, draw a voltmeter to measure the voltage across resistor R. So in order to find the voltage of resistor R, another wire should be joined across resistor R, and it should be joined to a voltmeter like this. So this voltmeter will give the reading for the voltage that is across the resistor S. So let's say this is voltmeter. Deduce the readings on the ammeters A1 and A2. Okay, so let's look at the diagram. A1 is over here, and we can see that there is a junction just before A1. And we know the total current in the circuit was 0.6, and as 0.4 ampere out of the 0.6 ampere went to resistor R, that means resistor S will get 0.6 minus 0.4, that is 0.2. So resistor S got 0.2 ampere of current, and as there is another junction before A2, so we can conclude that the 0.4 ampere travels to this, and the 0.2 ampere travels this pathway, and they both combine together at this second junction, and they combine together. So that means here at the second junction, the 0.4 adds up with the 0.2 ampere. So it will eventually give 0.6 ampere. So the reading on ammeter 2 will be 0.6 ampere. And we do not need to show the workings over here. We can just write it on the space given. That is 0.20 ampere on ammeter 1 and 0.60 ampere on ammeter 2. The resistor R has a resistance of 11 ohms. Calculate the voltage across resistor R. We can see from the diagram, like if you zoom into the diagram, you can see that as there is a junction between the wire that is connected to the battery and between the wire that is connected to the resistor R, so which means that the battery and resistor R are joined together by a parallel circuit. As they are in a parallel circuit, we all know in parallel circuits the current divides but the voltage remains the same. So in that case, so we can write this as V is equals to IR. We can solve this using the equation. We need to find the voltage across resistor R. So it will be 0.4 into 11, and you will get a value of 4.4 volt. So this is the value for the voltage across resistor R. So you need to write the answer in here, 4.4. Moving to part 4. Explain how the voltage across resistor R compares with the voltage across the battery. As I have already mentioned that the battery and resistor R are connected in parallel circuits, and in parallel circuits the only current divides, but voltage remains the same. That means the voltage across the resistor R will be the same as the voltage across the resistor across the battery. So the voltage across the battery and the voltage across the resistor R is same because they both are connected in a parallel circuit. So as it has only 2 marks, so I've already stated the points. Let's write it down. The voltage across the battery and resistor R is same because they are connected in parallel circuits. So moving to the next part. Diagram 2 shows a different circuit containing a battery and an ammeter and a thermistor. Explain how the thermistor can be used to vary the current in this circuit. So in this question, we need to carry out an investigation that how the thermistor can change the current in the circuit. We all know that thermistor has a variable resistance, and that variable resistance depends on the temperature. As the temperature increases, the resistance of the thermistor across the resistance of the thermistor decreases. So we are gonna use these points together and make it our answer. So let's start writing. The first point will be the resistance of the thermistor can be changed or changes. The resistance of thermistor changes when temperature increases. The resistance of thermistor decreases, and according to V is equals to IR, and according to V is equals to IR, as current as resistance decreases, current increases. So we have made a valid points that the resistance of the thermistor can be changed, and how it is changed by varying the temperature, because we know when temperature increases, resistance decreases, and according to V is equals to IR, as resistance decreases, the current flowing would obviously increase. So in this way we can change the current of this circuit using a thermistor. So this was the end of question number 3. Moving to the next part, question number 4. A student investigates how much pressure she exerts on the ground when she is standing up. The weight of the student on is 520 newtons. State the formula linking weight, mass, and gravitational field strength. We know the equation would be W is equals to mg, and we need to calculate the mass. And in order to do that, we need to make mass the subject of this equation, and it would be W by gravity, and that is 520 by 10. So you get a value of 52 kg. So the mass of the student was 52 kgs. The student measures the area of one of her feet when it is with contact with the ground. She draws around her foot on a piece of squared paper. So we need to find the number of squares in this area. So we are gonna select or count the entire square as one square and the half squares as these two half squares as one. So if you count all this, you will get a value of 39 squares. So under the foot there are 39 squares, and it is given that the area of the one square is actually 4 centimeters square. So we need to do some unitary method calculations. That is, area of one square is 2 into 2, that is 4 centimeters square, and the number of squares under the foot were 39. So the area of 39 square would be 4 into 39, and this gives a value of 156 centimeters square. The square on the paper has a length of 2 centimeter. Estimate the area of the student foot in contact with the ground. We have already found that the area in contact with the student's foot is 156 centimeters square. So we need to write it down over here, 156 centimeters square. State the formula linking pressure, force and area. So pressure is equals to force by area. The weight of the student is 520 Newton. We know that weight is a type of force, so we can say that the force is 520 newtons. Calculate the pressure the student exerts on the ground when she is standing on both feet. Both feet means that the area now will get double. So the area for both feet would be 156 into 2. I'm not going to calculate it, and then we will use this value into the equation, that is pressure is equals to force by area. The value for force would be constant because her weight doesn't double. Her weight would still be the same. So 520 divided by 156 into 2, and this will give you a value of 1.7 Newton per centimeter square, or you can write it as Pascal. So I'm going to write 1.7 and unit is pascals. So with this, our question number 4 ends. I hope it was clear. Question number 5. A bus transports passengers. The bus stops at certain points in its journey to let passengers get on or off the bus. The distance time graph shows part of the bus journey with sections labeled A to G. Give the letters of the sections where the bus is stationary. So we know, as it is a distance time graph, the horizontal lines indicate that the bus was stationary. So the horizontal lines were at B, D, and F. So these are the 3 points at which the graph was horizontal line, indicating the bus was stationary. So the answer would be B, D and F. Part A1 is done. Moving to part 2. Calculate the speed of the bus during section C of the journey. Give your answer in meter per second. So let's go back to the graph, and section C is this region of the graph. We need to calculate the y-axis difference and the x-axis difference. So in order to do that, I'm gonna label the axes together. So we can see that the section C ends at about 4.4 and section C starts at about 1.8. So it starts at 1.8 and ends at 4.4, and the x-axis value, it starts at exactly 5 and ends at 7. So the distance should be, the speed for this section should be speed is equals to change in y-axis divided by change in x-axis. That is 4.4 minus 1.8 multiply by 1000. We need to multiply it with 1000 because the the y-axis was labeled by kilometers, and we need to give our answer in the form of meter. So that's why we have to multiply 1000 to the y-axis difference and then divide the entire numerator by the difference of the x-axis. That is 7 minus 5, and if you calculate it, you will get a value of, let me calculate it, 4.4 minus 1.8 into 1000 divided by 2, and you get a value of 1300. 1300 meters per second. So the speed of the train during section C was 1300 meter per second. You need to write the answer in the space given. Explain part 3. Explain what the graph shows about the speed of the bus in section E compared with the speed of the bus in section A. So moving back to the graph, we can see that section E is a lot less steeper than the section A, and the less steeperness indicates that the speed has decreased, because the more the steeper, the higher the gradient. And as section A was the most steeper than section E, it indicates that the speed of the bus at section A was higher than the speed of the bus on section E. So let's write the answer over here. The answer would be the speed in section E. The speed in section E is less than the speed in section A, as the graph is less steeper. As the graph is less steeper. So part 3 ends. Moving to part B. Another bus travels a distance of 7 kilometers in a time of 14 minutes. The bus travels at a constant velocity. Complete the velocity time graph to show the motion of this bus. So we know that the initial velocity will be obviously 0, but the final velocity, we need to find the final velocity, and for that we need to divide the distance 7 kilometers by the minute, by the time, that is 14 minutes, and if you do this you will get a value of 0.5 kilometers per minute. So the value the value for the final velocity is 0.5, and now we need to draw a graph. We know 0.5 is around here, 0.5 kilometers per minute, and 14 is here, so the graph would end at this point and start from the origin. So you need to connect the 2 points together, and it will be a straight line, because it said that the velocity was constant. So it will be a straight line connecting the 2 points. So that's approximately how the graph would look like. Question number 5 ends. Moving to the next question. A teacher makes a hot drink. He puts the drink in a cup designed to keep the drink hot. The photograph and cross-sectional diagram both shows the cup. Explain how the design of the cup keeps the drink hot. Refer to method of energy transfer in your answer. Okay, so first let us examine the cross-sectional diagram for the cup. We can see that it has a plastic lid. We know that plastic is a good insulator. Insulator means it will prevent heat loss by conduction. So plastic, one point is good insulator. It prevents heat loss by conduction. So less conduction. Another thing is that it also traps a layer of air above the surface of the hot drink. So let us assume that the hot drink was up to this level. The plastic lid would trap some air in this area. And we all know, as air is a bad conductor or good insulator, so it will prevent heat loss by convection also. So the lid have two reasons. Now let's go to the vacuum part. As the two layers or the two surfaces are separated by a vacuum, vacuum means that the solids are not connected together. So again, vacuum prevents conduction, heat loss by conduction. So again, it is used for conduction part. And as all the surfaces, that is the inner metal surface and the outer metal surface, as both of these surfaces are shiny, that means that they will reflect heat. The inner surface would reflect heat inwards or will not absorb heat from the drink, and the outer surface will reflect heat outwards. So or it will not just emit heat from inside the drink. So that's why the shiny metal reduces heat loss by radiation. So there could be multiple answers for this, but we need to write only 6 points because it has 6 points. So let's start writing. The cup slows down energy transfer to the surroundings. The cup is designed to slow down energy transfer to the surroundings. It has a vacuum space, or it has a vacuum between the two surfaces. And a plastic lid which is a good insulator. All these prevents heat loss by conduction. Some air is trapped inside the cup by the plastic lid. So energy transfer from the surface by conduction is reduced. Transferred from the surface by convection is reduced. The inner shiny surface and outer shiny surface. The inner shiny surface and outer shiny surface are pore absorber and pore emitter of IR waves. So energy transfer by radiation is reduced. So with this, question number 6 ends. I hope it was clear. Moving to question number 7. A student uses a syringe containing trapped air to investigate pressure. Diagram 1 shows the apparatus. Diagram 2 shows the pressure gauge when the piston is at its initial position. Determine the reading on the pressure gauge. So let me zoom in a little. We can see that these two regions are 20 and 30, and there are 10 gaps between the numbers. So in that way, this will be 21, 22, 23. So this point would be 24. And as the unit is in kilopascals, so the reading over here is 24 kilopascal. So part A is done. Moving to part B. The piston is pushed in so that the volume of trapped air in the syringe is halved. The temperature of the air remains constant. Explain how the reading on the pressure gauge will change when the piston is pushed in. So let me explain it a bit first. So if we push in this will make the volume less, and we all know that pressure and volume is inversely proportional. As volume decreases, pressure would increase, obviously. So as we have decreased our volume by half, that means the pressure would increase twice. The pressure will now be double, double than the initial pressure. So now pressure is increased to 2. And why the pressure increases? Because the air particles now collide more oftenly with the walls of the syringe, so increasing the pressure automatically. So let's write the answer now. The pressure increases as volume decreases. The pressure increases as volume decreases. Pressure increases as volume decreases. So the reading doubles. So the reading doubles to 48 kilopascal. Because now the air particles collide with the walls more often. Collide with the walls more often. Moving to part C, the position of the piston is then fixed so that the volume of the air trapped in the syringe is now constant. The air in the syringe is then cooled. State how the motion of the air particles inside the syringe changes when the air is cooled. We all know when it is cooled, its kinetic energy decreases, and kinetic energy decreases, it means that its velocity will also decrease. So as it contains only 1 mark, you do not need to explain all this. You can directly write its speed decreases. Part 2. Explain how the pressure of the trapped air inside the syringe changes when the air is cooled. Refer to particle in your answer. So we need to define that why the speed of the particles actually decreases, and why the pressure of the particles decreases when the gases in the syringe are cooled. So the reason is that as pressure decreases, the particles will now collide less often with the walls of the syringe, so thus producing less force, and less force means less pressure. So let's write, as the kinetic energy, as their kinetic energy, it should be written as their kinetic energy decreases, they collide with the walls. They collide with walls less often with less force. With less force, according to pressure is equals to force by area. As force exerted decreases, or just as force decreases, pressure also decreases. As force decreases, pressure also decreases. And with this, question number 7 also ends. Moving to the question number 8. A car is moving along a road. The car has an initial velocity of 20 meters per second. This is the value for u. The car then accelerates at 1.2 meter per second square until it reaches a velocity of 35 meter per second. 35 is the final velocity and 1.2 is the value for the acceleration. Part A1, state the formula linking acceleration change in velocity and time taken. We know it is A is equals to v minus u divided by t. And now we need to find the time taken for the car to accelerate to 35 meters per second. So if we make t the subject of this out of this equation, the equation will be like V minus U divided by A, and it would be, the value for V is 35 minus 26 divided by 1.2, and you get a value of 7.5 seconds. So the car accelerated from 26 to 35 meters per second during 7.5 seconds. So the answer is 7.5. Part A is done. Moving to part B. A radar speed gun is used to measure the speed of the moving car. The radar speed gun emits radio waves towards the moving car. The moving car reflects the radio waves back to the detector on the gun. The detected radio waves have a different frequency from the emitted radio waves. This change in frequency is used to measure the speed of the moving car. Explain the change in these frequencies when the car is moving towards the radar gun, speed gun. So when the car would be moving towards the speed gun, it will start behaving like a source, creating waves, because the wave will reflect from the surface of the car, and due to Doppler effect, the frequency of the reflected wave increases. As the frequency increases, the wavefronts or the waves become more closer together, and as the waves become more closer together indicates that the wavelength decreases. And according to V is equals to lambda f, as lambda decreases, frequency increases, the overall change will be the same and the velocity therefore would stay constant. So let's start writing. The frequency increases due to Doppler effect, or let me first write that the car now behaves like a source of reflected waves. As waves are reflected from the surface, are reflected from the car, it behaves like a source of reflected waves. The frequency of the reflected waves increases due to Doppler effect. The reflected wavefronts become closer together. Decreasing the wavelength. According to V is equals to lambda f, the speed stays constant. I hope question number 8B was clear. And if you have any questions, you can obviously comment it in the comment section. Moving to question number 9. A teacher investigates the penetrating ability of the gamma rays from a gamma source. This is the teacher's method. Place the gamma source at a distance of 25 cm from a radiation detector. Place a 1 cm thick absorbing material between the source and the detector. Measure the radiation count from the source for a time period of 3 seconds. Calculate the count rate in counts per second. Repeat the measurement 2 more times. The teacher repeats this method for different absorbing materials. Name a suitable radiation detector that the teacher could use. We all know that is GM tube. So GM tube can be the best radiation detector, suitable radiation detector. State the independent variable in the teacher's investigation. We know the independent variable is the thing that we are changing, and the only thing that the teacher is changing in here is the absorbing material, right? So the independent variable is in this investigation is the absorbing material, because the teacher is using different absorbing materials, which indicates that it is changing entire the investigation. So the independent variable is absorbing material. Absorbing material. Part C, explain why every absorbing material used in this investigation has a thickness of 1 centimeter. So it is kept constant, because if one material has a thickness of 1.5 centimeter and the others have 1 centimeters, then the one with 1.5 centimeter thickness will produce less counts, because the thicker the material, the more it has the ability to block the radiation particles. So that's why, as the thickness of the absorbing material affects the count rate, so it should be kept constant to make this entire investigate a fair investigation. So let's write it down. Because the thickness affects the count rate, affects the count rate, and so it is kept constant. So it is kept constant for fair taste. Part D, suggest one improvement the teacher could make to this investigation. One improvement that I quickly thought of is that the time for which the radiation was counted was really small, that is 3 seconds. Right, so in this period, background radiation can also interrupt with the radiations from the main source. So that's why the time for which the radiation was counted should be a bit longer than 3 seconds, and also the count rate should be subtracted from the background radiation. The background radiation should be cancelled to give the exact count rate for the source only. So in that reason, if that's the case, so the answer should be the teacher should count over a longer period and subtract background count. The teacher should count over longer period and the background radiation count should be subtracted. So with this part D ends. Moving to the next part. The table shows the teacher's result for 7 different absorbing materials. On the grid, plot a bar chart of the mean count rate for each absorbing material. So we need to use this axis and these axes. This will be on the x-axis, because we know already that absorbing material was the independent variable and count rate was the dependent variable. So it will be on the y-axis. So I have already drawn the graph for part E1. So that's how it looks. It's a bar chart graph. We need to put the absorbing material on the y-axis and label all the bar charts for each material, and we need to put the x-axis and we need to put the count rate on the x-axis. So that's how it all looks. I hope part E1 is clear. Moving to part E2. Explain why a bar chart is correct way in this to display this result. We all know that the absorbing material was a not continuous variable. So in that way, part B is correct. It is not continuous because each material doesn't contain or doesn't absorb the count rate, or doesn't give a count rate that comes out in a pattern. It doesn't comes out in a pattern. If you look at the graph, it doesn't show any pattern. So that's why we need to draw it using a bar graph. We use a line graph for continuous variables and bar graph for not a continuous variable, that is discontinuous variable. So absorbing material was a discontinuous variable or not a continuous variable. So that's why a bar graph is the best way to represent these informations. I hope it was clear. Moving to part 3, our student concludes that plastic is the best absorber of gamma radiation because plastic gives the largest mean count rate. Evaluate the answer. We know that the student is wrong because if it would be the best, then it would give the least count rate, indicating that it has absorbed most of the radiations from the source and only a few are left out, and the left one radiations were detected by the detector. So as it gives the most count rate, it means that it is the worst absorber, and if you look from the graph, the least count rate gives lead. So in that way, lead is the best absorbing material because it absorbs most of the radiations from the source and the leftovers are detected by the radiators or detectors. So the answer would be, the student is wrong. The student is wrong because lower the count rate, the better the absorber. Lower the count rate, the better the absorber, and in this way we can indicate that lead is the best absorber. So therefore, or just therefore lead is the best absorber. Not plastic. With this, question number 9 ends. Moving to question number 10. This question is about light. Diagram 1 shows a light entering a glass prism. Describe what happens to the light ray when it enters the prism at point A. We know that as it is that light ray enters the glass prism at an angle that is less than critical angle. So due to change in medium, also the speed of the light changes, and as speed changes, the wave bends towards towards the normal, so it will refract. So the answer should be, due to change in medium, the speed of the wave decreases, so it slows down and refracts towards the normal, State the name of the line XY. We know this is an imaginary line and we call it as normal. So this is normal line. Part 2 is done. Moving to the next part. State the formula linking critical angle, refractive index. We know this is sine C is equals to 1 by refractive index. The refractive index for the glass in this prism is 1.6. Calculate the critical angle for the glass. So if we make C the subject, then it would be sine inverse 1 divided by 1.6, and you will get a value of approximately 39 degrees. So the critical angle is 39. Complete the diagram 1 by continuing the path of the ray from point B. We know at point B the medium associated are glass and air. Glass is more dense and air is less dense, so it will be totally internally reflected. That is, this will be the path for the ray. and with this arrow. So part 4 is done. Moving to part B, diagram 2 shows a similar prism that is made from a material with a different refractive index. The critical angle for the material of this prism is 55 degrees. Complete the diagram 2 by continuing the path of the light ray, as it has indicated that the critical angle for this prism is 55, and from the diagram we can say that the angle of incidence here would be 90 minus 50, that is 90 minus 40, that is 50 degrees. So as it has already indicated that the critical angle of incidence is less than the critical angle, so light will be refracted away from the normal. So it will go with this path like this. This will be the path for the refractive light. And with this, question number 10 ends. Question number 11. Technetium-99m is an isotope of the element technetium. Technetium-99m has a half-life of 6 hours. A sample of technetium-99m has an initial activity of 160 becquerel. Complete the graph to show how the activity of this sample of technetium-99 changes over a period of 24 hours. So in order to first draw a graph, we need to first draw a table about what are the points would be possible points for this radiation. So we need to first know that the half-life for this specific radiation is 6 hours, and the initial activity is given, that is 160 becquerel. So that means that after every 6 hours the activity will be half of the initial activity. So we can do a graph or draw a graph like this. So for the first on the first 0 hour the activity would be 160, and then on the first 6 hour the activity would be half of the initial, that is 80, and after 12 hours the activity will be half of the second activity, that is 40. After 18 hours the activity will be 20, and after 24 hours the activity will be 10. And if you go on, it will keep decreasing like this, but we need to stop at 24, because if you look at the graph, your axis is only leveled to 25, and the next activity or the next half-life will be on 30 hour, and our graph doesn't have that on the x-axis, so we will stop on 24. And now if we draw these points on the graph and join the lines, you will get a graph of this shape, and this is the exponential shape indicating the radiation of the or decrease in activity of the technetium-99m. So this is how the graph looks like, and that's with this the part A ends. You actually do not need to show the working, you just can simply draw the graph without any working and you will still get the full marks for this. So this is not compulsory. This calculation that I did is not compulsory. So moving to the next part. Part B, technetium-99 has a half-life of 6 hours and can be used as a medical tracer. It is injected into a patient's blood and moves around the patient's body. Technetium-99 emits gamma radiations, which is used to locate the position of the tracer in the patient's body. Technetium-99 does not exist naturally. They suggest why technetium-99 is usually made at the hospital where it is used. Because we have already seen that it has a half-life of 6 hours, which indicates that it decays very quickly. The rate of its decay is very fast. So when we are doing a medical procedure, like when we are doing an investigation on a body, we need to make sure that we injected a tracer whose activity is actually 0, because all our calculation starts with this 0 activity. So that's why, to make it the investigation more reliable, or to make the test more fair or valid, we actually make the technetium 99M isotope inside the hospital. So when they were injected inside the body of a patient, we make sure that their activity is 0 initially. So here, as it contains only 1 mark, so you can only write because it decays very quickly, because it decays very quickly. Very quickly. So with this, part A1 ends. Part B2, explain why technetium 99 is an effective isotope to use as a medical tracer. As it already said that it gives out gamma radiation, where it was mentioned somewhere that it gives out gamma radiation. So as we know that gamma radiation can penetrate outside the body, so we can detect where the tracer is, or where the radioactive material is moving inside the body by placing a detector on the body, or moving the detector where it gives a number of counts. So we can detect the movement or the path of tracer or path of radioactive material inside the body. And it also have a quite big half-life. So as it has a quite long enough half-life for the entire procedure to end, like it is not excessively long and it is not excessively short too, like it is in the medium range that is most suitable for us to complete the entire procedure for the test. So the reasons over here would be because it can penetrate outside the body, and it has a half-life long enough to complete the procedure. The gamma radiation emitted by technetium 99 is potentially harmful to humans. Discuss the risks of using technetium 99M to doctors and to patients. So we all know, as it releases gamma radiation, gamma radiation causes formation of cancerous cells by mutating normal cells. So as it produces or increases the risk of getting cancer, the patients and doctors should reduce the time with the gamma radiation, exposed to the gamma radiation. The patients are usually at a higher risk because they are the ones that actually absorb the gamma radiations, right? Because that is inside their body. The technetium 99M is inside the patient's body, so the patient actually receives the gamma radiations from the technetium 99, and so the patient is at a higher risk of getting or developing cancer. The doctor should obviously maintain a suitable distance from the patient because the patient is releasing gamma radiation, and the gamma radiation can obviously make his cells cancerous. So he should maintain a suitable distance from the patient to reduce the risk of developing cancers. So these are the possible reasons. Now let's write it down. First, write the harmful effect of gamma, that it can mutate cell and cause cancer. The gamma radiation can mutate cells and cause cancer. The patients are at a high risk of developing cancer because the technetium 99M releases gamma radiation inside their body, so they absorb some of it. The doctors should maintain a suitable distance from the patients to reduce the risk of developing cancer. Developing cancer. So with this, question number 11 ends. Moving to question number 12. The planet Mars and Saturn orbit around the same star, the Sun. The diagram shows the orbital paths for the Mars and Saturn. Draw an orbital path for a comet on the diagram. So we know that the planets have more circular orbits around the Sun, but the comets always have the elliptical path. Elliptical path are the ones that is already drawn in the diagram. So the diagram for the comet or the orbit of comet will be something like this. The Sun should be at the center, and there should be an elliptical path around the Sun and showing the position of the comet at any specific point. I draw it over here because I like that position, but you can obviously draw at any position on the comet, on the purple line that is drawn. That is the orbit for the comet. So this is the end of part A. Moving to part B. The table gives us some information about the orbits of Mars and Saturn. Mars complete a number of rotation orbits in the time it takes for Saturn to complete one orbit. Calculate the number of orbits that Mars completes in the time it takes for Saturn to complete one orbit. So now this question says that the time it takes for Saturn to complete one orbit, Mars can by that time Mars can complete a few orbits. We don't know the number that is under the word few, but we know that it completes more than one orbit by the time Saturn completes one orbit. So the time for the two periods are same. So let us find the time for one complete orbit for Saturn. We know the time, the equation for this is V is equals to 2 pi r by t, and as we need to find the time for one complete orbit, we will make t the subject. We are doing this for Saturn, by the way. So let's write Saturn on the top. V is equals to 2 pi r divided by t, and if you make t the subject, it will be 2 pi r divided by velocity. The value for r of Saturn is 1.3 into 10 to the power 9. So it will be 2 pi into 1.43 into 10 to the power 9 divided by time, velocity. Velocity is 9.7, and if you calculate it, 2 pi into 1.43 into 10 to the power 9, sorry, 2.43 into 10 to the power 9 divided by 9.7, you get a value of 926284019 seconds. So you get this much big amount of time for one complete rotation of, or one complete orbit of Saturn. Now we need to find the number of time for one complete rotation for Mars, and we can do this by using the same equation. So we are now finding the time Mars take to complete one orbit. So if we take V the subject, it will be 2 pi radius of Mars orbit of radius of the orbital radius for Mars is 2.28 into 10 to the power 8. 2.28 into 10 to the power 8 divided by its velocity is 24.1, and if you calculate it, 2 into pi into 2.28 into 10 to the power 8 divided by 24.1, you get a value of 59442582.99. Sorry, let's move it over here. Let me write it down again. 59442582.99 seconds. So Mars needs this much time to complete one rotation. So 59442582.99 seconds, it completes one orbit, and in 926284019.5 seconds it will complete 1 divided by 59442582.99 into 926284019.5. And if you divide this, you will get the value for number of rotations Saturn does in this period. Let me calculate it. 59442582.99, and you get a value of 15.58 approximately to 3 significant figures. So you'll get a 15.6, and as the question said, you need to find your it didn't say that you need to give your answer to the nearest number, but we cannot say that the number was 15.6. So let us decide between 15 and 16. I will choose 15 because it says 15 complete rotation with 0.6 rotation. So that's why I'm gonna write 15 number of orbits. So it has traveled or completed 15 number of orbits by the time Saturn has completed one orbit. And this is the end for the calculation. This is the end of the calculation for question number 12, and also the end for the entire paper 1 physics January 2020. And if you have any questions after solving the questions and after even watching the video, you can comment it in the comment section. I would really like to solve it, or you can email us the problem on our email address, that is edexcel@gmail.com. The screenshots of the entire video or the answers of the questions will be uploaded in our Facebook page. You can find the link for the Facebook page in the description box. And if you like the video, give it a thumbs up, subscribe to our channel, and thank you for watching.